Hello, my little mathematicians. Today, I'm going to help you do the ratios, rates, and proportions study guide. Okay, now remember, at any point in time, you're always welcome to pause the video, give it a try, and then unpause it and come back and join us, or fast forward or rewind the video. Okay, let's go ahead and take a look at this first section. It says, the woman walked 6 miles in 2 hours. First, it wants you to write the ratio. So we have miles per hour, right? And 6 miles in 2 hours. Okay, now we're not focusing on reducing or anything. As of right now, is this a rate? Yes, it's units of measurement, right? It's miles and hours. So it is a rate. Is it a unit rate? Not yet, because it doesn't have a denominator of 1. It could eventually be, but as of right now, it's not. Okay, this one, we're talking about dogs to cats. Okay, and they say that there's 9 dogs for every 5 cats in the store. Is that a rate? No, that's just a normal ratio, because in order to be a rate, it has to be measured in like units of measurement. So you don't measure in terms of dogs and cats. Okay, so that one's just a ratio, not a rate, and then therefore not a unit rate. Okay, the next one says the sign said 3 boxes of cereal for $5. So this is how much money per box of cereal. And it says it's $5 for 3 boxes. Is that a rate? Yes, because we're like talking in terms of measurement and money. Is it a unit rate? Not yet. We would have to find out how much it is for 1 box in order to be a unit rate. Okay, this one is money per burrito, and it's $7 for 1 burrito. Okay, obviously that one is a rate, but is it a unit rate? Finally, yes, it is, because it had a denominator of 1. And that's what a unit rate is. It's like how much does it cost for just one item, or how far can you go in 1 hour, etc. So this one is in miles per hour, and you can go 85 miles per hour since there's no number there. That's saying it's per 1, which means, you guessed it, it is a unit rate, which means it is a type of rate. Okay, you're not so much going to be tested on that. It's just we were trying to reiterate the fact that if they ask you to find the unit rate, make sure that you fully reduce it, okay, so that your denominator is 1, okay, versus this one is just a rate, and you would just leave it like that. The one thing I want to point out is please, please, please don't change this to a mixed number of 1 and 2/3, because what this is saying is the top number is how much money it is, and the bottom number is for how many boxes of cereal. And it's not, oh, it's $2 for 3 boxes. No. Okay, is it 1 plus 2, $3 for 3 boxes? No. Is it $12 for 3 boxes? No. Okay, so it's $5 for 3 boxes. Don't try to change this to a mixed number, because then you'll just be confused. Okay, leave it alone like that. All right, I just wanted to point that out, because I know like a lot of you guys are in the habit of changing improper numbers to mixed numbers. Not in this ratio unit, because you want the top number, again, to be describing the top thing, and the bottom number to be describing whatever the bottom's talking about. Okay. Let's go ahead and take a look at number 6. It says there are 15 fig trees and 5 olive trees on the farm. Write the fully simplified, okay, so fully reduced, ratio of fig trees to olive trees in 3 different forms. Okay, it matters. Whatever they say first before the word to goes on top, and whatever they say second after the word to goes on bottom. So they want the fig trees to olive trees. And they said for fig trees there was 15, and for olive trees there was 5. Now, can that reduce? Yes, it can, by 5. So then your answer is 3/1. So that's one form. The other form is if it's separated by a colon, and the other one is if it's separated by the word to. Okay, so those are the 3 different forms of ratios. And then you don't want to write the 3 forms until after you've fully simplified it. Okay, why don't you go ahead and try the next one by yourself? Okay, you unpause the video and you're back with us. They want to know the advanced class has 12 boys and 18 girls. Write a fully simplified ratio of girls to boys. Okay, well, for girls, there's 18. And how many boys are there? They said 12. Can anything go into 18 and 12? Yeah, 6 can. And 18 divided by 6 is 3, and 12 divided by 6 is 2. Can you reduce it any more? Nope. So 3 over 2 is your final answer. Okay, for this one, we're going to use this table on the right here, and it says, the table on the right shows the number of breakfast items sold by Betty's Breakfast Shop on Monday morning. Use the information provided on the table to answer questions 8 through 13. And then, what is the fully simplified ratio of wheat bagels to plain bagels? So they want wheat on top and plain on the bottom. Now, if there's ever like a bunch of words that just look too, like if there's too much for you, circle this and then put the one before it, underline once, and the one after the word to, underline twice. And then that's just a visual of like this to this. Okay, because sometimes I get overwhelmed by all the words too. Okay, now look up in the table, and how many wheat bagels did you see? 13. How about how many plain ones? Yep, 9. Can that reduce? Well, 3 is the only number that can go into 9, and can 3 go into 13? Nope. So you're done. Okay, next one. What is a fully simplified ratio of wheat to all? So wheat bagels to, and instead of just putting all, you want to be specific because it's not all things, it's all bagels that are sold. Okay, so here's the bagel section, and the amount of wheat we said was 13, and then for all, it's both the plain and the wheat, so you would add those. And what is 9 plus 13? Yeah, 22. And then you just, before you like move on to the next problem, want to double check to see if it can reduce. Well, 13's prime, so the only way to reduce it is if 13 could go evenly into this, and it can't, so we're done. What is the fully simplified ratio of banana muffins to orange muffins? So we want banana to orange. So look at the muffin section, and the orange amount was 6 muffins in that pack, and oh, nope, I messed up right here. Banana was actually 8. It's love be tired. And orange muffins was 6. Okay, now what can go into both? Yep, 2. And what's 8 divided by 2? 4. And what's 6 divided by 2? Yep, 3. And that can't reduce anymore, so we're done. Okay, last row. What is the fully simplified ratio of blueberry muffins to non-blueberry? Okay, this one's getting wordy, so I'm just going to underline. We have blueberry to non-blueberry. And we're focusing on just the muffins, so right here. So the blueberry is right here, which is 24. And then non-blueberry, look at all of these, and it's basically all the ones that, what do you think? Yeah, all the ones that aren't blue. So you're going to have the banana, the bran, and the orange. So you have 8 plus 8 plus 6. So 8 and 8 is 16, and 16 plus 6 is 22. So you have 24 to 22. Wow, that must be the really popular muffin because all the other muffins together don't even equal how many blueberry there are. What can go into both? Yeah, 2. So go ahead and reduce that. And then what's your final answer? 12 over 11. Good job. Okay, the next one, they want the ratio of orange muffins to all muffins sold. Okay, well, orange is here, is 6. And then all of the muffins are all of these, which was, we know this, this, and this is 22. Now add in the blueberry. So what's 22 plus 24? Yep, 46. Okay, go ahead and to reduce that. What can go into both? Yeah, 2 can. And 6 divided by 2 is 3. And 46 divided by 2 is 23. Can I reduce it again? Nope. Okay, last one for this page. It says, write the ratio of all bagels to all muffins. Okay, well, all bagels we already did up here. We said was 22. And all muffins, we said right here, was 46. So what can go into 46 and 22? Yeah, they're both even, so 2 can. And on top, 22 divided by 2 is 11. And on bottom, that reduces to 23. Can it reduce any more? Nope, you're done. All right, time to move on to page 2 of our study guide. Okay, it wants to know 6 ratios that are equivalent to 4/10. Okay, why don't you go ahead and pause the video and try them yourself. Okay, you unpaused it, you're back with us. And I want to point out that as long as you do the same thing to both the top and the bottom, they'll work out. So as I'm doing this, please not freak out. Oh my gosh, I didn't get the same thing she did. I'm wrong. Again, as long as you did the same thing to both the top and the bottom and you didn't make a math there, you're fine. Okay, it'll still work out. So um, if we go ahead and take a look at 4/10, I want to first ask myself, can it reduce? Yeah, it can reduce by 2. So what is 4 divided by 2? 2. And what's 10 divided by 2? 5. Can that reduce any more? Or can anything else go into 4 and 10? Nope. So I did say that you could multiply or divide, right? So we divided. Now let's try maybe multiplying both the top and bottom by 2. And you're like, how can I do this? Why does this work? Well, think about it. Okay, essentially you're doing 2 over 2, right? And 2 over 2 is just 1. So if you multiply anything by 1, isn't that the same answer, right? Anything by 1 is itself. So I'm not really changing the value of 4/10. I'm just multiplying it by a value of 1 because the same number over itself is 1. So when I do this, I get 8/20, which is just another way of writing 4/10. Okay, and then how you can check you're right is it should reduce down to the same thing. They all should reduce down to 2/5. And if all of your ratios that you found reduce down to 2/5, then you know you're right. Okay, so my next one, I would do times 3. And on top, you get 12 and then 30. Okay, but you don't have to do that. Like, literally, you could do whatever you want. Okay, like, let's skip 4 and let's do times 5. Why not? Okay, as long as you do the same thing to the top and bottom and you actually multiply correctly, you don't put 4 times 5 is 21. Okay, well, then you're going to miss it because that's not right. 4 times 5 is 20 and 10 times 5 is 50. Okay, ooh, this one reminds me, one of the easiest things to do when you're trying to find equivalent ratios, multiply it by 10 because then you just tack a 0 on. Now you have 40 and now you have 100. There you go. Okay, so here are just some equivalent ratios. Again, these aren't all of them. You could have multiplied it by like 62 or a million or a billion or a trillion. As long as you did the same thing to the top and bottom and you didn't make any math errors, they're going to be equivalent. Okay. Um, the next one says Mrs. Key's first grade classroom has 19 students. 8 of the students are boys. Write the ratio of girls to boys. Okay. I'm just going to color code these because sometimes they get a little bit confusing. So it says that there is a total of 19 students, right? And then 8 of these are boys. And they want to know the ratio of girls to boys. So they want girls on top and they want boys on the bottom. Well, did they tell me how many are girls? No, but they did tell me that there's 8 boys. And you're like, great, but they didn't tell me how many girls, so how do I figure it out? Well, they did tell me there's 19 total students and that 8 of those 19 are boys. So then to find the number of girls, you would do, 19 minus 8, which is 11. And then that tells me that there's 11 girls. Can you reduce that? Nope, you're done. Okay. This one says a bracelet has 42 beads that are either black or gold. Okay, so that's the total amount of beads then. Then it says 18 of the beads are gold. Okay. And they want you to write a fully simplified ratio of black to gold. Okay, so black to gold. And they did tell me that there's 18 gold, but they didn't tell me how many black there are. So how do I figure that out? Well, you're right. Okay, they told me the total. So what would I do with the total in order to figure out how many black there are? Yeah, subtract how many 18 there are, how many gold there are, 18. And then that's going to tell me the leftover amount is how many are black. And when you do 42 minus 18, you get 24. Then you just ask yourself, can that reduce? Yeah, I can reduce that by 2, and you get 12 over 9. But don't forget, ask yourself if it can reduce again. Don't forget about 3, okay? 3 can go into a lot of numbers. 12 divided by 3 is 4, and 9 divided by 3 is 3. And you get final answer of 4/3. Now, some of you guys are like, oh my gosh, wait, I didn't divide by 2. I divided by 3 first. Okay, you still would have gotten there. Then you just would have divided by 2 second. Or others of you are like, I divided by 6. Yeah, you just got there faster. 24 divided by 6 is 4. 18 divided by 6 is 3. So the bigger the number you choose to divide by, the faster you get to your fraction. Okay, just don't forget to keep going till you can't go anymore. All right, next one says a train travels 452 miles in 7 hours. Write the unit rate in miles per hour. Okay, so miles was 452, and they did that in 7 hours. To find the unit rate, that means they want the denominator to become 1. So how do you go from 7 to 1? Yeah, if you divide it by itself. You could do that as long as you do the same thing on top. So what's 452 divided by 7? 64 point, I got this weird number, 5714, and it keeps going. But if you get a number that keeps going and going and going in your calculator, look at the directions. They probably tell you what to round it to. And this one says round it to 2 decimal places, or round it to the hundredths. Okay, so I just need to go one place further than that. Does this 1 tell the 7 to stay a 1 or go up? Yeah, it tells it to stay. So you have 64.57 miles per hour. Now, just a little refresher about rounding. If the one behind the number you're focusing on is 5 or above, then that 7 would have bumped up to an 8. But if the one behind it is 4 or below, then that would stay a 7. And the 1 fell into the 4 or below category. That's why it stayed a 7. The only time it wouldn't tell you to round off if like you needed to is if it's dealing with money, because obviously it's understood that money rounds to how many places? Yep, 2 places. Okay. Next one says it costs $16.45 for 5 pounds of ground beef. What is the unit price? Well, the unit price is a specific unit rate that's dealing with money. So you're doing money per pound, and it's $16.45 for 5 pounds. So again, you want to find the unit price. You want to find how much is it for just 1 pound of meat. So what you would do is, how do you get from 5 to 1? Yeah, divide by 5, and then do the same thing on top. Well, what's 16.45 divided by 5? $3.29 for 1 pound of ground beef. Okay, last one for this section says 12 small bags of chips cost $9.48. What's the unit cost? Okay, well, for unit cost, remember, you want to find how much it is for 1 bag of chips. Well, they say it's $9.48 for 12 bags. So to get from 12 bags to 1 bag, you would, divide by 12, and then do the same thing on top. Well, 9.48 divided by 12 is 79 cents. So it's 79 cents per bag of chips. Don't I wish? Okay, we need to tell that to all the sandwich places, right? Okay. The next one says the double number line shows the ratio of cheese pizza to pepperoni pizza ordered by students. Fill out the missing number. It looks complicated, but don't overthink it. Go towards the direction of your unknown, which is this box right here, right? So then do the same thing here. Now ask yourself, 8 times what is 56? Yeah, 7. So then 5 times 7 is 35. That would be your missing number. Looks complicated, but super easy, huh? Okay, the only thing to watch out for these is, try this one on your own. Okay, now that you're back with us, I really hope you got this right. If you went towards the direction of your unknown, that means you went this way. And how do you go from 6 to 2? Yes, divide by 3. So then I'm going to divide 21 by 3, and I should have gotten 7. If you weren't paying attention, you probably did 21 times 3. So always draw the arrows like towards the direction of your unknowns, and you know you're going from the 6 to the 2 and not the 2 to the 6. That's the only trap for these. Otherwise, super easy. Okay. The next one says a marinade recipe calls for 3 tablespoons of sugar for every 2 tablespoons of salt. Gross. If Carissa is going to be using 12 tablespoons of salt for her marinade, how much sugar will she need to use? Okay. So the two things I'm talking about are what and what? Yeah, sugar and salt. So this first sentence says that it's 3 tablespoons of sugar for every 2 tablespoons of salt. So those go together. Now for my next ratio, the number I see is 12, and what's it talking about? Yeah, salt. And where does salt go? Where did we put it? On the bottom. Okay, so that's where the 12 should go. And then how much sugar? We don't know, so that's my variable. Okay, if we could solve it the shortcut way, I say we do that. If not, we can do cross products. Can I do the shortcut? Yes, because 2 times what is 12? 6. So then 3 times 6 is 18. So it's 18 tablespoons of sugar. That's what I was solving for, right? It's in the sugar row, which makes sense because it says how much sugar will she use. Done. Okay, the next one says the ratio of children to adults at the carnival is 7 to 3. Okay, let's stop there. The ratio is children to adults. So children over adults. And the ratio is 7 to 3. So whatever comes first, that's representing the children. And whatever comes second, that's representing the adults. There we go, 7 over 3. Then it says if there are 21 adults at the carnival, how many children are there? So when there's 21 adults, where would I put that 21? Yeah, on the bottom because it's talking about the adults. And then we're trying to find how many children there are when there's 21 adults. Can I do the shortcut? Well, go towards the unknown and let's see. 3 times what is 21? 7. So 7 times 7 is 49. So when there's 21 adults, there is 49 children. That's a lot. Okay. A jewelry maker creates necklaces with red and green. Okay, so let's see here. Okay, we have red and green beads. And then that's in a ratio of 5 to 8. If a medium necklace has 56 green beads, then how many red beads will it have? Okay. It says 56 is representing what? The number of green beads. And where are green beads? On the bottom. And then we're going to solve for the amount of red beads. So in the red section, that's the unknown. Let's see if we can do the shortcut. 8 times what is 56? 7. So 5 times 7 is, you guessed it, 35. So there's going to be 35 red beads when there's 56 green beads. Okay, last one for this page. It says a farm has 32 white sheep. If all the sheep are either black or white, and the ratio of black to white is 1 to 8, then how many of the sheep are black? Okay, so black, it says the ratio of black to white. So the top is black, the bottom is white, which means the first number here is representing the black, and the second number in that one is representing the white. So there's my first one. Then I use the other piece of information to fill out this ratio. And what's 32 talking about? Yeah, it's talking about the amount of white sheep. So then we want to find how many black sheep there are when there's 32 white. So let's see if we can do the shortcut. Yeah, 8 times what is 32? 4. So then 1 times 4 is 4. So there's going to be 4 black sheep when there is 32 white sheep. Perfect. We are just moving right along, aren't we? Okay, last page. Don't forget, if you haven't been pausing the video and trying them yourself first, please be doing so. Because you want to know how well you'd actually do before we do it together. Okay, it says there are 28 students in dance class, and the ratio of girls to boys is 4 to 3. How many of the students in the class are girls? You're like, yeah, Miss Love, do it yourself. And then you give me a hard one. Okay, you got this. Girls, there's the first number. So girls is 4. To boys, so the second number is representing the boys, and there's 3 of those. And then you're like, okay, so the 28 is talking about neither of them. It's talking about the number of total. I'm like, all right, so then what do I do with that? Like, I don't have the number of girls or boys to subtract them to find the missing piece. Here's what we do with this. Okay, they want to know how many what there are, how many girls. So we want to get girls, and then we're given the number of total students. So we know that when there's 28 students, we're trying to find how many girls there are, right? So that's this ratio. But we also know something else. We know that when there's 4 girls, how many boys are there? 3, right? So when there's 4 girls, how many total students are there? Well, 4 girls and 3 boys is a total of 7 students, right? So when there's 4 girls, there are 7 total students. So I used this to help me get this ratio right here. And now I can figure out how many girls there are when there's 28. Okay, so let's see if we can go do the shortcut. 7 times what is 28? 4. So then 4 times 4 is 16. So there's going to be 16 girls when there's 28 total students. Okay, definitely try this one on your own. Okay, you're back with us. It says a farm grows only cherry trees and peach trees. Okay, so you have cherry and peach, and the ratio is 1 to 3. So cherry is on top, and it's representing 1. And for every 1 cherry tree, there is 3 peach trees. Okay. Then they said, if the farm has 96 trees, how many of them are peach? And you're like, great, they told me the total again. And we want to find the number of peach. So we have peach to total. Well, what did they tell me here? They told me that there was 3 peach trees, right? When there's 3 peach trees, how many total trees are there? There's a total of 4. And you're like, how did I get that? Well, when there's 3 peach trees, there's also 1 cherry tree for a total of 4 trees. Okay. And then they asked, okay, so then when there's 96 total trees, how many of those trees are peach? Now go ahead and try to solve this. Go towards your unknown, towards your unknown. 4 times what is 96? Yeah, 24. So then 3 times 24 is 72. So there's going to be 72 peach trees when there's 96 total trees. And you're like, that seems like a lot of the majority of them. Well, yeah, because there's 3 peach trees for every 1 cherry tree. There is a lot more peach trees. So my answer makes sense. Okay, for 28, the first part wants you to find the unit rate in dollars per hour. So what would be nice is if the graph was right here in like per hour, I could look at this dot and be like, oh, follow the line. But sadly, that dot is not on the graph. So I'm going to find an exact dot right here. And when you do, the unit rate is dollars per hour, right? Well, this dot is $20 for, and you're like, oh, wait, actually, what do you know? It did hit at 1. So use the graph to your advantage, okay? So it's $20 for 1 hour. And then you're going to use that to help you figure out how much he's going to make after 40 hours, okay? So again, we have dollars per hour. We already know that $20 is 1 hour. So then in 40 hours, where do I put that 40? On the bottom, because that's where hours is. We're going to solve for how much he's going to earn. Go towards your unknown. So towards your unknown. 1 times what is 40? Yep, 40. So then 20 times 40, 2 times 4 is 8, and then tack on 2 zeros. How much is it? Yep, $800. So he's going to make $800 in 40 hours. Okay, now this one, the reason I like purposely act confused a little bit last time is because sometimes you actually can't find the exact dot for like 1, right? Like here, when you want to find the amount per taffy piece, it's not actually on there. So I would have to use this first dot right here, which is saying how much money per taffy. It is $1 for 4 pieces of taffy. So if you want to know how much it is for one piece of taffy, because remember that's after the word per, so this is what they want to become 1. How do you go from 4 to 1? Yeah, divide by 4. And so then when you do that on top, 1 divided by 4 is 0.25. So that's 25 cents per piece of taffy. And before you overthink that, you're like, oh, wait, yeah, 25 cents for a little taffy piece. That does make sense. So then if it's 25 cents for one piece of taffy, how much is it going to cost for 1,000 pieces of taffy? Well, let's set up our proportion. Okay, use that information, 25 cents for one. So then for 1,000 pieces, how much is it? Where do I put 1,000? Well, it's representing the number of taffy pieces, so on the bottom. And then we're going to solve for the money amount. So my variable is with the money, because that's what I'm solving for. Go towards your unknown. 1 times what is 1,000? Yeah, 1,000. So then do the same thing on top. And what's 0.25 times 1,000? What'd you get? Yep, 250. Perfect. Okay, next one. It says write the unit rate in dollars per pound. Okay. So what number should I put on top? The one for the money, right? And which one is that? This right here. So it's $1.49 for 1 pound. I don't even actually have to do anything to solve for it. It literally gave me the unit rate. Done. Then it's saying how much would 7 pounds of broccoli cost? Okay, well, we're doing dollars per pound. So use the fact that it's $1.49 for 1 to then figure out how much it's going to be for 7 pounds. Okay, go towards your unknown. So that's this way. 1 times what is 7? Yeah, 7. So then 1.49 times 7 is 10.43. And this is the money we're solving for. So it's $10.43. And then double check. Yeah, it asked how much would it cost. So I solved for the right thing. Last problem. You got this. Okay, write the unit rate in calories per minute. Well, sadly, this one didn't give me the unit rate. Didn't tell me like how much it is in 1 minute, right? But I still can do this. Okay, it wants calories per minute. So let's write that, calories per minute. And this first point, you can use any of the points you want. This one just is smaller numbers, so I'm going to use that one. Okay, 21 calories in 5 minutes. But you want to find the unit rate, so you want the denominator to become 1. You want to know how much it is for just 1 minute. Well, how do you go from 5 to 1? Divide by 5. So do the same thing here. What is 21 divided by 5? 4.2. So this unit rate is that you can burn 4.2 calories per minute. Done. Okay, now I'm going to use that information to answer this last question. Okay, it says how many calories would Andrew burn if he walked for 45 minutes? Okay, well, calories per minute. You could use this, but if you feel uncomfortable, like what if I missed it? Fine, then use one from the table, right? If he did 21 calories in 5 minutes, then you want to know, where am I going to put that 45? Yeah, on the bottom because it's talking about minutes. And then you're going to solve for how many calories he can burn. So then go towards your unknown, which is this way. 5 times what is 45? 9. So then 21 times 9 is, 189. So he can do 189 calories in 45 minutes. Now, if you did it with the unit rate that we just found up here earlier, okay, you can see like you still would have done 4.2 calories in 1 minute. So then 1 times 45 is 45. So then you would do this times 45. You still would get 189. So you could use technically any of the points from this table or even the unit rate. And as long as you didn't make a mistake in finding the unit rate, then yes, you still are going to get the same answer. Okay. Congratulations, my little mathematicians. You should now be a master of solving ratios, rates, and proportions. You're going to do awesome.